the first thing we need to do is to find the error when calculating the volume of the ball bearing. First, we need to find the volume of the ball bearing, which is 4/3 pi r to a third power. And by calculating that, we need to find volume 2 minus volume 1. So first, we're gonna do the volume number 1, which is 4/3 pi times 1.5 to the third power, and it will give you
14.137
centimeters
cube. Centimeters cube.
And after that, we need to find the volume 2, which is putting the maximum error into the radius. Instead of being 1.5, it will be 1.52, which will be volume 2 is equal to 4/3 pi 1.52 to a third power, and that will give you
14.710
centimeters cubed. After that, the last step, you need to plot the volume 2 minus the volume 1, and that will give you the error. 14.710 minus 14.137,
which is 0.573.
0.573, and that will be your answer for letter A. So the next step is we need to do volume 2 minus volume 1, and that will give you the error, which will be 14.710 minus 14.137,
which is 0.573.
0.573, and that will be your answer for letter A.
In part B, we have to find the estimate when calculating the appropriate error in the volume of a ball bearing. To do this, we first have here the formula for finding the volume of a sphere. We have to find the derivative for this, which is dv over dt equals, we multiply 4 times 3, which is 12, divided by 3, we'll simplify that later, times pi, and then we subtract 1 from 3 because we used it to multiply 4, and according to our rule, this becomes radius squared. We now have to just plug in our values to get our final answer, which is dv over dt equals, we simplify this, which is 4 pi over 1.5 squared multiplied by our maximum error, which is 0.02.
4 times pi. The answer is 0.565.
0.565. This is our final answer. In part C, we have to find the approximate change and change if the company produces 500 ball bearings daily. We do this, we have our change here, 0.573. We multiply this times 500, which gives us
286.5.
286.5. This is our exact change, and now we have to find the approximate change, which we basically do the same, which is 0.565 with our approximate change instead of our actual change, multiplied also by 500, which should give us a similar number.
282.5.
282,
which the difference is basically 4.
Since, yes, that's...
And it's basically the same.
This is our approximate and actual change. In part D, we have to find the density of aluminum and steel and determine the approximate and the actual change needed to produce them. To do that, we have to find the kilograms per centimeter squared of both aluminum and steel, which are 0.0027 and for aluminum, and for steel it's 0.00805 for kilometers per centimeter squared. And to find how effective the cost would be to produce a single ball bearing, what we have to do is multiply our densities by the approximate and actual changes, and we get the numbers here. And as we can see, producing them in aluminum would be much cheaper because buying 1 kilogram of aluminum would be a lot much more cheaper than buying 1 kilogram of steel. As you can see here, there is a pretty big difference in the numbers.
We needed to change it to kilograms because the question asks us to change it to kilograms.
Letter E asks us about what we think about the situation, and we think if we were the company producing the ball bearings, we would produce them out of aluminum because it's a much cheaper material that you can buy with the current budget you have. Because buying 1 kilogram of aluminum gives you much more to produce, and it is much cheaper than buying 1 kilogram of steel.
Hello, this is problem number 3
of section number 2.
So this is the equation we have to integrate. First of all, this is equals to 1 minus 4x 3/2 because of the square root.
And you need to move this to the top because you need to have all the equation in the top and not in the bottom, so it becomes a negative.
Don't forget the negative. And the dx. Okay? So you have to find which one is your u. Your u is this. U is equals to 1 minus 4x squared. And you have to find that u prime, which is the derivative of this.
Negative 8x.
Okay? Then you have to write again the problem. We don't have to write again all this, so we just put a u.
So it becomes
And
du equals,
and you have to divide by negative ax, which is your u prime. So 28 divided by 8 is 28x divided by negative ax. The x cancels out and it's 7/2. So integration sign 7/2 u negative 3 divided by 2. That is your final equation. And you have to integrate now. So 7/2 u plus 1 plus 2/2 because that's basically 1. So u negative 1/2 and this divided by negative 1/2. So now that we have to divide by 1/2, we can do the tortilla method, which is outer, inner, which is 14 divided by 2, and it's negative. We simplify,
it's negative 7.
negative 7. So negative 7 u negative 1. So this is our equation. We must write it with a u, the equation. So negative 7 the u
4x squared
and the exponent that we have before. 1/2 plus c. This is our final answer. We can still move down this equation and put it in a square root.
Because it's a negative, you need to move the equation to the bottom.
So it can be positive.
So it can be positive.
And because it's dividing, it's a square root.
Plus c.
Plus c.
And this is our final answer.